In this video, we're going to see INX instruction. So, if you remember what INR did, INR was used with a 8-bit register, which basically incremented the 8-bit value by 1. But what INX does is, INX is always used with a register pair, which means the register pair sum total is of 16-bit. That means INX basically increases the 16-bit value by 1. Suppose, say, we take a pair BC which contains the value 1, 2, 3, 4H. So what INX does is, if we implement INXB, then the content of BC register will go to 1, 2, 3, 5H. You might say, I could also do INRC for this particular case. Well, you are correct. But there are cases where similar scenarios might not occur. Example, say we have 10FFH in DE pair. Suppose if we want to increment the DE pair 16-bit value by 1, the result should go to 1100. But if you do INRE, what this will do is, it will not touch the register D. The content of the register D will be intact, but it will only change the content of register E, which means FF. So if we add 1 to this, there will be a carry flag, but the sum total result in 16-bit will be 1000, which is not the correct answer. So in this case, if I do INXD in place of INRE, what this will do is, it will take the pair value in a unified manner, and then the carry will be considered in this particular addition. So 1 plus 0 is 1, and then the result is 1. So this is how we use INX instruction. And then I guess you also got the point where INX and INR are not the same. One more thing to remember is, using INR will affect some flags. You can see the status of the result after INR in the flags, but INX will not affect any flag. You need to remember this. Any flag. Okay, I hope you got the point. This is how we use INX instruction in 8085.